Today we will start Unit 5, Covalent Molecules. In our previous videos, we just covered ionic compounds, so we're going to move forward now and talk about when two nonmetals bond together to form a covalent molecule. Before we begin, let's review electronegativity. Remember that electronegativity is how much an atom attracts an electron. Keep in mind that metals do not attract valence electrons. Metals always give away their valence electrons, whereas nonmetals want electrons, so they should have a high electronegativity. Like I said, metals do not attract electrons, therefore they have low electronegativities. Nonmetals love electrons. We call them electrophilic. And there's one atom in particular that loves electrons the most, and that is fluorine. Fluorine has the highest electronegativity of any atom on the periodic table. Fluorine has an electronegativity of 4. You should have received one of these periodic tables that tells you the electronegativities of each atom on the periodic table. Notice here with fluorine, we have an electronegativity of 4. And it is the highest of all the electronegativities on the periodic table. Here we see our stair-step line, which separates your metals and your nonmetals. Notice how all of the metals have lower electronegativities than the nonmetals. That's because nonmetals will attract valence electrons so they can have 8 valence electrons to satisfy the octet rule. Whereas your metals will give away their electrons to satisfy the octet rule. Please keep this periodic table handy as we talk about electronegativities. Within a covalent bond, we are going to form bonds by sharing valence electrons. This is different than ionic bonding, where the metal transfers electrons to the nonmetal. Now that we are talking about the bond between two nonmetals, they will be sharing their valence electrons. So we'll have 2 or more nonmetals sharing their valence electrons. We can have 2 types of covalent bonds. This is where you will need your periodic table with electronegativities printed on them. We can have a nonpolar covalent bond. In a nonpolar covalent bond, your difference in electronegativities will range between 0 and 0.3. This is because your electrons will be shared equally in this molecule. Now, when we say the difference in electronegativities, you need to find your elements on the periodic table to determine what their electronegativities are. For example, let's say we have a bond, a covalent molecule of 2 hydrogens. And we want to determine if this is a nonpolar covalent bond. We are going to use our reference that you have printed out in front of you, and we're going to find hydrogen. Hydrogen has an electronegativity of 2.1. Since we have 2 hydrogen atoms, and we're looking for the difference in electronegativity, we're going to do 2.1 minus 2.1, which is in fact 0. Therefore, this is within the range of being a nonpolar covalent bond. The other type of covalent bond that we can have is what we call a polar covalent bond. The difference in electronegativities for a polar covalent bond is 0.4 to 1.7. This is because your electrons will not be shared equally within the bond. For example, let's look at water, H2O. We're going to find hydrogen on the periodic table, like we just did. Its electronegativity is 2.1. And then we're going to find oxygen. Oxygen's electronegativity is 3.5. The difference in electronegativities here, 3.5 minus 2.1 is equal to 1.7. 0.4, which falls in the range of being a polar covalent bond. Here, I have drawn a molecule of water. Notice how we have 2 hydrogens and 1 oxygen. These straight lines here represent the bonds between hydrogen and oxygen, and these 4 dots here represent valence electrons. If we look at this molecule, we can see that oxygen has more electrons surrounding it than the hydrogens do. Therefore, the electrons are not being shared equally, which is why it is a polar covalent bond. Here, we can see 2 hydrogen atoms bonded together. Notice how there are no extra valence electrons surrounding these hydrogen atoms. Therefore, they are sharing all of their electrons equally, which makes it a nonpolar covalent bond. On your worksheet, you are to determine the type of bond between the following atoms. Please use your periodic table that has electronegativities printed on them to determine what type of bond these atoms will create. Pause the video. When you are finished, continue on with the video. So with our electronegativities, you will have a higher electronegativity when there are more electrons present. This will indicate that you have a slightly negative charge, and we indicate a slightly negative charge with this symbol here. If we have a low electronegativity, that end of the molecule will have a slightly positive charge, and it's shown with this symbol here. This is what we call a dipole. A dipole means that we have 2 poles. Now these poles will be a positive pole and a negative pole on the molecule. I will show you on the next slide what we mean. So here we have our 2 hydrogen atoms again. Notice how there are no extra valence electrons around them. Here's what the bond looks like in 3 dimensions. And if we wanted to look at the electron cloud, we can see that the electron cloud for both atoms are about the same size. Therefore, we have no polarity. In this molecule here, with hydrogen and fluorine, here you can see the bond, and notice how many extra valence electrons fluorine has surrounding it. If we look at it in a 3-dimensional model, here's the hydrogen, which is clearly smaller than the fluorine, in which case the electrons are not being shared equally. This is indicated again here with the electron cloud models. Here you can see our fluorine atom has a high concentration of electrons, which gives it its slightly negative charge because electrons are negatively charged. On this side, you can see that we have a slightly positive end. That's because all the electrons are being pulled away from this side of the molecule to the fluorine side of the molecule. We can indicate this with what we call a dipole arrow. This dipole arrow is going to point to the slightly negative end, and at this side we'll have the positive end of the molecule. It is called polar because we have a positive pole and a negative pole, versus nonpolar, where all the electrons are being shared equally, therefore there's no slightly negative or slightly positive side of the molecule. I've been saying this word molecule a lot. That's because when we have a covalent bond, we call them molecules, versus an ionic compound, which we refer to as salts. There are a few special molecules that we call diatomic. Di meaning 2. So we have 2 atoms here. There are 7 of them on the periodic table that will never exist by themselves. So they will always come in pairs. They are hydrogen, nitrogen, oxygen, fluorine, chlorine, bromine, and iodine. Here are some models that show you the diatomic molecules. Notice how they come in pairs. There are a couple of different ways that you can remember the 7 diatomic molecules. Here we have an acronym, Brinkelhoff. My personal favorite is the 777. If we look at our periodic table, here we have nitrogen, oxygen, fluorine, chlorine, bromine, and iodine. They make a 7 on the periodic table. Nitrogen is element number 7. So we have 7 diatomic molecules that make a 7 on the periodic table, starting with element number 7. And then, of course, we have little hydrogen over here. That is the exception to all of the rules. He's diatomic as well. He's just not part of the 7 here. But this is one easy way to remember your 7 diatomic molecules. Please write these down on your worksheet. When you have finished that, you can continue the video. So we've talked about the octet rule in our previous videos. Remember that the octet rule states that all atoms want to have 8 valence electrons. Of course, there are some exceptions to this rule. Hydrogen will only have 2 valence electrons because it's so teeny tiny that it cannot hold any more than 2. And then we have boron. Boron can hold 6 valence electrons. Remember that our covalent molecules are going to share their valence electrons so they can create a couple of different types of bonds. If we're going to share 2 valence electrons, we will create a single bond. For example, let's say we have 2 fluorine atoms together. Here are 2 fluorine atoms, and each one of these small marks here represents valence electrons. If we look at this atom of fluorine, it has 1, 2, 3, 4, 5, 6 valence electrons, but it's also going to create a single bond with another fluorine atom, and it's going to share 2. So now it has 8 valence electrons. This fluorine also has 8 valence electrons now because it's sharing. It has 1, 2, 3, 4, 5, 6, 7, 8 valence electrons. This bond right here is the single bond. It is the longest in length, and it will also be the weakest type of bond. Next, we can have a double bond. In a double bond, you are sharing 4 valence electrons. For example, let's say we have 2 oxygen atoms bonded together. These are the oxygen atoms, and each one of these little marks up here represents an electron. Here, we have a double bond. In this double bond, we are sharing 4 valence electrons. 1, 2, 3, and 4. So now if we look at this oxygen atom, it has 1, 2, 3, 4, 5, 6, 7, 8, which fulfills the octet rule. This oxygen atom does as well. 1, 2, 3, 4, 5, 6, 7, 8. The last type of covalent bond we're going to talk about is what we call a triple bond. Here's an example of a triple bond. We have 2 nitrogen atoms. Each nitrogen atom will have 1, 2 electrons over here and 1, 2 electrons over here. And notice how they are sharing 1, 2, 3, 4, 5, 6 electrons here. So now if we look at this nitrogen atom, it has 1, 2, 3, 4, 5, 6, 7, 8 valence electrons, which fulfills the octet rule. This nitrogen atom does as well. This type of bond will be the shortest and the strongest type of bond. Pause the video so that you can complete how to draw a single bond, a double bond, and a triple bond on your worksheet. That concludes this video.